Hello everybody, today we're going to be talking about masses of the atoms and the periodic table, which is sections 2 and 3 of chapter 16. First thing we want to talk about today is the atomic mass. Now, remember we talked already about the structure of the atom, and I mentioned previously that most of the mass of the atom is in the nucleus. And if we see here in this little chart that the amount of mass for the electron is a negative 28, or if you want to do the relative, it's 1 of 1,840. So electrons are very, 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 very tiny and weigh almost nothing compared to the protons and the neutrons. This brings up an atomic mass unit. That's just one of the ways that we measure protons and neutrons. And so basically it's notice here the AMU, the atomic mass unit. A proton is just slightly over 1.007, right? That's the 7,000th. And a neutron is 1.008, all right? So basically we round that and just say it's 1. Whereas, again, the electron is 1 of 1,836. So it's a very, very small amount. So when we talk about AMUs, we're basically talking about protons and neutrons, okay? The atomic mass unit. Another thing that we use when we talk about atoms and the periodic table of the elements, we talk about the atomic number. Now, the atomic number is equal to the number of protons in the nucleus. And it's also the same number that they are for the element. So element number 1 is hydrogen because hydrogen has 1 proton in the nucleus, and so on and so forth. The atomic number is also the number of protons and electrons. So typically speaking, most of the time your atoms are balanced. So if you have 10 protons, you're going to have 10 electrons, and you have a balance. Now, there are obviously some exceptions to this rule, but generally speaking, the atomic number will give you both the number of protons and the electrons. Here is one of what we call an atomic number card. And this is what you'll see on the periodic table of elements. You'll have an atomic number, which is at the top. And then you have the symbol, which is the symbol or the letters that describe the element. This would be C for carbon. And then it would have the atomic mass on the bottom, like actually how much does it weigh. And those are generally in AMUs. Okay. And so we can see here that we know, again, because the atomic number is 6, that there are 6 protons in a unit of carbon. Okay. Now, if you know one of the following, you can figure out the other two. The name of the element, if you know the name, you should be able to figure out the atomic number and the number of protons. Remember, the atomic number and the number of protons are the same. Okay, so don't get kind of messed up with that one. So if you know the atomic number of the element, it's relatively easy to find the name of the element and, again, the number of the protons. Another thing that we talk about when we talk about atoms, we talk about the mass number. Now, the mass number is the number of protons plus the number of neutrons, okay? And the reason we say that is because basically the protons and the neutrons have all the mass in an atom. Remember, the electrons are very, very light. So the mass number is just the number of protons and the number of neutrons, okay? Is the mass number the same as the atomic mass? No, it is not, because it's merely a count of the protons and the neutrons. We're just counting them. Okay, so remember, the mass number has the word number in it. Has the word number in it. All right, so mass number is just a count. Okay, and remember, if you know the mass number and the atomic number, you can calculate the number of neutrons. Why is that? Well, because remember, the atomic number is the number of protons. So mass number minus atomic number gives you the number of neutrons. And this is important because a lot of elements have different isotopes. And an isotope is an element that has different neutrons in it, and then it has different properties because of those. Okay, we'll talk about isotopes right now. An isotope is, again, the atom of the same element, but it has different numbers of neutrons. In the picture over here, it shows an example of hydrogen. There are a couple of 3 hydrogens, right? But one has a neutron, right? One has 2 neutrons, but they're still hydrogen. This one just shows different neutrons, and so they call it protium, deuterium, and tritium. Okay. The protons, remember, don't change, because if you change the proton, you change the element. Okay. We change the number of neutrons, and this is written basically to show that it's an isotope. We would say hydrogen 2. Okay. That would let you know that there are 1 neutron, 1 proton, or tritium here would be hydrogen 3. Okay. Again, carbon 14 is a very common one used to dating old things in the dirt, in the earth, organic matter. Use carbon 14. Isotopes have a different characteristics due to the different numbers of neutrons. Okay. Now we're going to move into the periodic table. Now, the reason we have a periodic table is because we're trying to organize the elements. Elements all have characteristics, the atomic mass, atomic number, and then the properties. And as people are discovering new elements, they're finding out all the different properties, and they're finding out that some of these elements have similar properties, even though they had a large number between them. There was a large gap. And so they're trying to sit there and arrange them. And what Mendeleev did, he just arranged the elements in a repeating pattern. And what that allowed him to do was to predict elements that hadn't been discovered yet. And he was basically going off of their the atomic number and the mass, the AMUs. And he said, okay, so I have these characteristics here, but I'm missing one here, that there should be a repeating pattern. It follows this sequence. And that's how he laid out the periodic table of elements. And when we get into it, you'll understand and see the patterns by which he labeled. Moseley, he was the one who basically made the largest edit ever to Mendeleev's table. Mendeleev is credited with creating the periodic table of elements. And mostly unknown is that Moseley changed it to increase the atomic number left to right. Mendeleev had it, if I remember right, a vertical column. Mendeleev basically turned it on, or Moseley turned it on its side so we could read it from left to right as we do conventionally read everything else in the English language. One of the things that we need to know about the periodic table of element is that every table has a key. And the periodic table's key basically shows some basic information. We have the name, we have the numbers, we have the atomic symbol, and we have the mass. And they're all laid out generally this way, with a large symbol in the middle, the number and the name toward the top, and the mass toward the bottom. Sometimes the name can be moved around, but generally speaking, the symbol is in the middle, the number is on top, it has a number of protons, and the mass is on the bottom. And this is just the average. Now, because there are many different isotopes, we have to average the mass, right? Other important characteristics, let me move my recording here, about the periodic table elements are follow. The horizontal rows, the ones that go across the bottom, all right, they're called periods, okay? Vertical columns, all right, the ones that go up and down, they're called groups, okay? And another name for those groups are families, and those are basically the ones in the vertical column that share properties. They all are very, very similar, and so we call them a family. A region is a larger area of the periodic table element that has specific names, and we'll get to those in a little bit. Some of the most common regions, the three big ones, are the metals, the metalloids, and the non-metals. Okay, and here is a periodic table with the family names. Remember, family are basically a group that has similar properties. So we have on the far left under hydrogen, we have the alkali. Then the next one over is the alkali earth metal. In the middle, the large small section is called the transition metal family. And then we have the boron, the carbon, the nitrogen, oxygen, halogen, and then the noble gas family. We'll talk about all these different families and more so the groups that they're arranged with. Okay, and so here's the periodic table of elements. Right, and then in the bottom we have the lanthanide and actinide, which get inserted over here, and which basically causes a large gap. So we just kind of take those out, okay, to make it more condensed. Electrons are really important because electrons are all about bonding. And so if we understand how the table's laid out according to protons and also electrons, it makes a lot more sense when we're doing bonding and we're writing chemical formulas and understanding how certain things react, because reactivity is merely electrons moving from one set to another set and the bonds and sharing. Okay, so as the table progresses from left to right, the atoms all gain one electron. Okay, so if we look at hydrogen, if hydrogen is on the far left, it has one, and then the corresponding group on the far right side, because there's just one and one at the very top, would be helium, and that has two, which means two protons and two electrons. So again, most of the time, your electrons follow the same route as the atomic number. So one proton and one electron are added to each element as you move across the row. And the reactivity and the things that we'll learn about is basically because an element wants an electron or it has extra electrons and wants to get rid of them. And it's because of this sharing process that causes the reactivity between different families and different groups in our periodic table of the elements.